Okay, so this brings us to our next optimization. There's a lot of fun little optimizations. And this is one that actually is no longer talked about in your textbook. The older versions of your textbook did talk about this optimization. But I think it's still an important, interesting optimization to think about. And this is something called a victim cache. The victim cache, let's take a look at the picture first here. You have your CPU, L1 cache, L2 cache, so multi-level cache. But now, if you miss in your L1, we put another little spot to check. We put something we call a victim cache. And a victim cache is a fully associative cache, but it's usually very small. So let's say 1, 2, 3, 4 entries, something like that. So it's very small cache structure here. But it's fully associative. And what's nice about this is sometimes in programs, you have a problem where, I don't know, let's say you have a two-way set associative L1, but you have 3 things that want to be in that one location of the cache, so one index of the cache. So they just keep fighting and just knocking each other out over and over and over again. Just actually one extra fully associative entry would solve this. And then you can have data here in the way 0, in way 1, and now in this victim cache. So this is actually I think the first processor this showed up in was an HP PA RISC processor. Probably HP 7000, if I recall correctly, or 7000 series processor. But you could actually have this little extra cache here. A couple extra things you need to think about, though, is whether you check this cache in series or in parallel with the L1. If you check it in parallel, it's going to hurt your hit time. If you check it in series, check this first, then check this, and then check the L2. Checking these together is going to have a worse hit time, but you can leave your L1 sort of fast and alone the way it was, and you don't have to put an extra multiplexer after your L1 check. It's a trade-off. People have built both, checking both in parallel and in serial. Let's look at the mechanics of how this works. So on a miss in our L1, where we're generating a victim, we actually transition the victim to here. And then we bring in the new data from here into the L1. Unless the data is in the victim cache already. And then all we need to do is basically swap the two. Take the line that's in the victim and the line that's in the data and swap them. And usually you have sort of separate data paths to do that. You can have that going on simultaneously. So you can have the one data going on one into the other and vice versa. If you miss in the victim cache, miss in the L1, interesting question comes up here. Data that's in the victim cache, what happens to that? We put a victim in the victim cache. Do we need to do something with that victim? Sort of this question mark here. Unclear. It really depends on our design. If the design is such that whenever we generate a victim from the L1, we both put it in the victim cache and we flush it out to our L2. Then when we have to, let's say, victimize from the victim cache, the victim cache, let's say, only has 2 entries, and we need to put a new victim in the victim cache, we can just throw it on the ground. We don't actually need to do anything with that victim because the data is known to be out in the L2 safely. If not, we'd actually have to take data from the victim cache that's possibly dirty and go right out into the L2. But in reality, what this is trying to do is it's trying to reduce our conflict misses by giving us a pseudo higher associative cache with just a very small set. And it's interesting to look at sort of the papers that describe this, the people who have implemented this. This victim cache, a very small victim cache, can go a long way. Because there's lots of times in your program, there may be that one value or that one address, which is what's highly contended in your cache, or it's alias lot in your cache. But everything else in the cache is just sort of capacity limited, we'll say. And this can really help you with the conquest. Okay, so going back to our victim cache here, if we look at the sort of victim cache just by itself, to the L1, this is kind of looks like a multi-level cache. So the answer is going to be the same as what we had for our multi-level cache. If you look at it just for the L1, it's going to make the miss penalty go down, or it's going to be good for the miss penalty. If you look at the L1 with the victim cache, both the miss penalty will be lower than if we had to go out to the next level cache,